Literate programming is an approach to programming introduced by Donald Knuth in which a program is given as an explanation of the program logic in a natural language, such as English, interspersed with snippets of macros and traditional source code, from which a compilable source code can be generated. The literate programming paradigm, as conceived by Knuth, represents a move away from writing programs in the manner and order imposed by the computer, and instead enables programmers to develop programs in the order demanded by the logic and flow of their thoughts. Literate programs are written as an uninterrupted exposition of logic in an ordinary human language, much like the text of an essay, in which macros are included to hide abstractions and traditional source code. Literate programming tools are used to obtain two representations from a literate source file, one suitable for further compilation or execution by a computer, the tangled code, and another for viewing as formatted documentation, which is said to be woven from the literate source. While the first generation of literate programming tools were computer language specific, the later ones are language agnostic and exist above the programming languages. Concept: a literate program is an explanation of the program logic in a natural language, such as English, interspersed with snippets of macros and traditional source code. Macros in a literate source file are simply title-like or explanatory phrases in a human language that describe human abstractions created while solving the programming problem, and hiding chunks of code or lower-level macros. These macros are similar to the algorithms and pseudocode typically used in teaching computer science. These arbitrary explanatory phrases become precise new operators, created on the fly by the programmer, forming a meta-language on top of the underlying programming language. A preprocessor is used to substitute arbitrary hierarchies, or rather interconnected webs of macros, to produce the compilable source code with one command, and documentation with another. The preprocessor also provides an ability to write out the content of the macros and to add to already created macros in any place in the text of the literate program's source file, thereby disposing of the need to keep in mind the restrictions imposed by traditional programming languages or to interrupt the flow of thought. Advantages according to Knuth, literate programming provides higher quality programs, since it forces programmers to explicitly state the thoughts behind the program, making poorly thought-out design decisions more obvious. Knuth also claims that literate programming provides a first-rate documentation system, which is not an add-on, but is grown naturally in the process of exposition of one's thoughts during a program's creation. The resulting documentation allows authors to restart their own thought processes at any later time, and allows other programmers to understand the construction of the program more easily. This differs from traditional documentation, in which a programmer is presented with source code that follows a compiler-imposed order, and must decipher the thought process behind the program from the code and its associated comments. The meta-language capabilities of literate programming are also claimed to facilitate thinking, giving a higher bird's-eye view of the code and increasing the number of concepts the mind can successfully retain and process. Applicability of the concept to programming on a large scale, that of commercial-grade programs, is proven by an addition of text code as a literate program. Contrast with documentation generation literate programming is very often misunderstood to refer only to formatted documentation produced from a common file with both source code and comments which is properly called documentation generation or to voluminous commentaries included with code. This is backwards. Well-documented code or documentation extracted from code follows the structure of the code, with documentation embedded in the code. In literate programming, code is embedded in documentation, with the code following the structure of the documentation. This misconception has led to claims that comment extraction tools, such as the Perl plain old documentation or JavaDict systems, are literate programming tools. However, because these tools do not implement the web of abstract concepts hiding behind the system of natural language macros, or provide an ability to change the order of the source code from a machine-imposed sequence to one convenient to the human mind, they cannot properly be called literate programming tools in the sense intended by Knuth. Example: a classic example of literate programming is the literate implementation of the standard Unix WC word counting program. Knuth presented a CWEB version of this example in Chapter 12 of his Literate Programming book. The same example was later rewritten for the non-web Literate Programming tool. This example provides a good illustration of the basic elements of Literate Programming. Creation of macros. The following snippet of the WC Literate program shows how arbitrary descriptive phrases in a natural language are used in a Literate program to create macros, which act as new operators in the Literate programming language, and hide chunks of code or other macros. The markup notation consists of double angle brackets that indicate macros, the @ symbol which indicates the end of the code section in a non-web file. The closing angle bracket symbol stands for the root, topmost node the Literate programming tool will start expanding the web of macros from. Actually, writing out the expanded source code can be done from any section or subsection, so one Literate program file can contain several files with machine source code. Note also that the unraveling of the chunks can be done in any place in the Literate program text file, not necessarily in the order they are sequenced in the enclosing chunk, but as is demanded by the logic reflected in the explanatory text that envelops the whole program. Program as a web. Macros are not just section names. Macros are not the same as section names in standard documentation. Literate programming macros can hide any chunk of code behind themselves, and be used inside any low-level machine language operators, often inside logical operators such as if, while, or case. This is illustrated by the following snippet of the WC Literate program. In fact, macros can stand for any arbitrary chunk of code or other macros, and are thus more general than top-down or bottom-up chunking, or than subsectioning. Knuth says that when he realized this, he began to think of a program as a web of various parts. Order of human logic, not that of the compiler, in a non-web Literate program. Besides the free order of their exposition, the chunks behind macros, once introduced with equals, can be grown later in any place in the file by simply writing equals, and adding more content to it, as the following snippet illustrates. Record of the train of thought. The documentation for a Literate program is produced as part of writing the program. Instead of comments provided as side notes to source code, a Literate program contains the explanation of concepts on each level, with lower-level concepts deferred to their appropriate place, which allows for better communication of thought. The snippets of the Literate WC above show how an explanation of the program and its source code are interwoven. Such exposition of ideas creates the flow of thought that is like a literary work. Knuth wrote a novel, which explains the code of the computer strategy game Colossal Cave Adventure. Tools. The first published Literate programming environment was Web, introduced by Donald Knuth in 1981 for his text typesetting system. It uses Pascal as its underlying programming language and text for typesetting of the documentation. The complete commented text source code was published in Knuth's Text, the Program, Volume B of his 5-volume Computers and Typesetting. Knuth had privately used a Literate programming system called DOC as early as 1979. He was inspired by the ideas of Pierre-Anouilh de Monve. The free CWEB, written by Knuth and Silvio Levi, is web-adapted for C and C++, runs on most operating systems and can produce text and PDF documentation. There are various other implementations of the Literate programming concept. Non-web is independent of the programming language of the source code. It is well known for its simplicity, just 2 text markup conventions and 2 tool invocations are needed to use it, and it allows for text formatting in HTML rather than going through the text system. Literate is a modern Literate programming system. Like non-web, it works with any programming language, but it produces pretty printed and syntax-highlighted HTML, and it tries to retain all the advantages of CWEB, including output formatted like CWEB. Other notable advantages compared with older tools include being based on Markdown and generating well-formatted tangled code. See external links. FunnelWeb is another LP tool that can produce HTML documentation output. It has more complicated markup, but has many more flexible options. Like non-web, it is independent of the programming language of the source code. Web can translate a single LP source into any number of code files in any mix of languages together with documentation in LaTeX. It does it in a single invocation. It does not have separate weave and tangle commands. It does not have the extensibility of GNU-Web, but it can use the listings package of LaTeX to provide pretty printing and the hyperf package to provide hyperlinks in PDF output. It also has extensive indexing and cross-referencing facilities, including cross-references from the generated code back to the documentation, both as automatically generated comments and as strings that the code can use to report its behavior. Vims is a type checker for Z notation which shows the use of GNU-Web in a practical application. Around 15,000 lines of GNU-Web source are translated into nearly 15,000 lines of C++ code and over 460 pages of documentation. See external links. Molly is an LP tool written in Perl, which aims to modernize and scale it with folding HTML and virtual views on code. It uses GNU-Web markup for the literate source files. See external links. Kotner is an inverse literate programming tool available as a Ruby gem. Instead of the machine-readable source code being extracted out of the literate documentation sources, the literate documentation is extracted out of the normal machine-readable source code files. This allows these source code files to be edited and maintained as usual. The approach is similar to that used by popular API documentation tools, such as JavaDoc. Such tools, however, generate API reference documentation, while Kotner generates a linear narrative describing the code, similar to that created by classical LP tools. Kotner can coexist with API documentation tools, allowing both a reference manual and a linear narrative to be generated from the same set of source code files. The Leo text editor is an outlining editor which supports optional GNU-Web and CWEB markup. The author of Leo mixes two different approaches. First, Leo is an outlining editor, which helps with management of large texts. Second, Leo incorporates some of the ideas of literate programming, which in its pure form is possible only with some degree of inventiveness and the use of the editor in a way not exactly envisioned by its author. However, this and other extensions make outline programming and text management successful and easy and in some ways similar to literate programming. The Haskell programming language has native support for semi-literate programming, generally inspired by CWEB but with a significantly reduced functionality and simpler implementation. When aiming for text output, one writes a plain LaTeX file where source code is marked by a given surrounding environment. LaTeX can be set up to handle that environment, while the Haskell compiler looks for the right markers to identify Haskell statements to compile, removing the text documentation as if they were comments. However, as described above, this is not literate programming in the sense intended by Knuth. Haskell's functional, modular nature makes literate programming directly in the language somewhat easier, but it is not nearly as powerful as one of the web tools where Tangle can reorganize in arbitrary ways. The Web68 literate programming system uses ALGOL68 as the underlying programming language, although there is nothing in the preprocessor Tang to force the use of that language. Emacs org mode for literate programming through Babel, which allows embedding blocks of source code from multiple programming languages within a single text document. Blocks of code can share data with each other, display images inline, or be parsed into pure source code using the GNU-Web reference syntax. CoffeeScript supports illiterate mode, which enables programs to be compiled from a source document written in Markdown with indented blocks of code. See also, SWEV and Nitra examples of use of the GNU-Web-like literate programming tool inside the language for creation of dynamic statistical reports, self-documenting code source code that can be easily understood without documentation. References. Further reading. External links, literateprogramming.com, https, wev.co.uk. An online literate programming environment. Comp Programming Literate FAQ at Internet FAQ Archives, Literate Programming Newsgroup, Literate Programs. A literate programming wiki. Select a literate programming example using GNU-Web, Literate, a modern literate programming system. GNU-Web, the GNU-Web literate programming tool. Vim's a real project developed using web. Vim's alternate source of Vims. Soft panorama page on literate programming, Haskell literate programming, specification of literate programming in the Haskell report. The accepted Haskell standard, NoWeb a simple, extensible tool for literate programming, Molly a standalone tool in Perl, which extends LP with folding HTML, and uses NoWeb markup, Kotner a an inverse literate programming tool, Funnelweb a complete standalone tool for LP independent of target language, LP for all a simple literate programming tool with a WOCI-like markup syntax, PyWeb, literate programming tool that will work with any markup language and any programming language. OrgBabel an org mode extension for literate programming in Emacs. Using Dokebook markup for literate programming. Known as XWEB, raw file a small media key extension implementing a basic form of literate programming. Shuffle takes files with chunks of text defined in shuffle notation, and filters these chunks according to a requested selection of variant and aspects. It is a part of EHC-UHC. Knuth, literate programming. Knuth's homepage containing information and errata for literate programming. Restructured text to code, a tool for LP from restructured text documents. Doco, a simple literate documentation generator by Jeremy Ashkenas.